development of a sustainable manufacturing system. And this part relates to chapter 4 in the textbook Sustainable Manufacturing, and I will bring up some key points addressed relating to this part. And the first is related to the development process of manufacturing systems for sustainable operation. So the phases in manufacturing development relates to ensure environmental sustainability during each phase of the development process, specifically during the early phases. Especially for early phases, they usually defines quite a lot in the operation phase. While at the operation phase, you can do very little to change things really. So the early phases are the key points in most developing phases, if it is a product or a manufacturing system or whatever it is, so to say. And the interrelated development of product and manufacturing system to consider the development as a long-term portfolio or the product and manufacturing system with an integrated perspective where the existing system as well as contextual stakeholders play key roles. And what one can say here is that it is quite seldom that a manufacturing system is developed from scratch based on a completely new product. It happens, but not so often. It's more often that a manufacturing system evolves over the time due to the fact that there is a product that also evolves over time. It changes. There are new variants on the way, new market opportunities or market threats and competition and so forth. So this kind of evolvement over time is more usual the case than designing a completely new manufacturing system from scratch. And most likely, I mean, in most cases, environmental sustainability, well, the phases in the manufacturing system development process is usually pictured as a state-gate process with a close integration to the product development. Or I would say the continuous development of products over time, because products develops all the ways over time in a steady state, more or less, with new variants defined by customer requirements or technological opportunities. So there is usually an initiation phase with project directives and resource plan, then a pre-study phase resulting in a requirement specification and refine plan, then the conceptual design phase with a solution in accordance with the requirements, the detailed design phase, refining and planning the solution, adaptation and purchasing, resulting in procurement of equipment and services related to this, and implementation phase with acceptance tests, and a launch phase, acceptance test and start operation. And then there should be note about this, that purchasing and procurement is usually referred to as commissioning in many cases. I will have that in another talk related to manufacturing systems. And that includes FAT, the FAT, factory acceptance test. And then that is the testing of equipment that is procured for a production system. And that acceptance test takes place at the company that set up the whole system for the customer which is buying it. And then almost everything that should be able to test is tested at the site of the system integrator. And then there is a site acceptance test, SAT, that is done after the FAT is accepted. The whole system is taken down, transported to the end user, set up, and then there is a site acceptance test, and the whole thing is tested on site in a manner that is accepted by both parties. And usually it is a way that, from a commercial point of view, that after the site acceptance test is accepted, the final payment is done. And also, one can consider that developers and tests might be necessary before a process can be applied. A process, I mean a manufacturing process. That depends if there is a standardized process to be carried over in the specific equipment, or if it's a new, rather new kind of process, manufacturing process. I mean, and how novel things are, and that has to be considered. If it's a major thing, everything should be standard. If it's a new novel thing, things have to be developed over time and checked and so forth. And of course, in every step along the way, over time, checks related to sustainability, legislations, directives, etc., should be made, because those changes also over time. So what was allowed a year or 2 years ago may not be allowed today or the next year. So things has to be applied and watched quite careful that way. A few comments related to design, redesign, and reconfigure. And that relates to that the most common case is actually that an existing manufacturing system or factory exists. We have existing equipment, an existing structure, a specific flow in the factory, a layout. We have resources to consider. We have people to consider. I mean, we cannot just change these kind of things. They exist. So that means that we, in most cases, don't have a white paper to start with. We start with something that is existing. So design related to complete a new product line is really uncommon. And even if that is the case, so if some kind of structure exists anyhow, some boundary conditions around what we are thinking about. And what is more common is a redesign or a reconfiguration related to changes during a product lifetime, with new variants, upgrades of a product that add to requirements within the manufacturing systems. And there are new legislations or directives imposed by governments may require changes in the manufacturing systems. That includes processes that are applied, materials that we use, or new materials that we should use, and quality control definitely. So these things come into play, so to say, over time. And a company not really considering these changes will have a hard time competing with global competition, so to say. So that will be a challenge. And then a few comments related to the portfolio of a product and manufacturing system. There is figure 4.3 with the manufacturing system development process. The upper circle aligned to product development, the lower circle and product lifecycle horizontal process. So if we have this horizontal here with the part manufacturer, we have sourcing and inbound logistics, moving to the product manufacturer, outbound logistics, user repair, end of use treatment, end of life treatment, and in reality, somehow in a circular economy goes back with the reuse of materials or reuse or of parts of what can be reused, so to say. And then we have the product development cycle, which goes or flows in the normal product requirements, portfolio alignment, conceptual product design, the detail and process planning, product introduction. And in the same way, we have the initialization and pre-study, manufacturing requirements, conceptual design and portfolio alignment, the detailed manufacturing system design, and then we have the procurement of manufacturing equipment, implementation and ramp up and launch. And all this goes concurrent over time in most operations and have to go concurrent over time. Uh, of course, I mean, there are cases where someone develop a product and then they offshore production of whatever is designed. And that is fine. I mean, that can go on in if you offshore more simple components or part of a product and very well specified, and then they can come back. I mean, to the assembly for a more complex product, but more complex products offshore might pose some problems when they are integrated and get to be working. There are Then a few comments related to methods for analysis of environmental aspects. So there are three interrelated perspectives related to the process-based perspective, the resource-based perspective, and the activity-based perspective. And this view should be managed simultaneously. And it's a sort of optimal solution based on multidimensional optimization for all three aggregated views. And the process-based perspective relates to the production flow of individual products and value-adding processes. And in a way, I mean, that is influenced by lean production concepts that will be viewed and taken up in the chapter 5 based lecture related to lean production. The same with the resource-based perspective. That is about utilization of production resources, such as equipment, materials, energy, machinery, personnel, and so on. And there are different key performance indicators, KPI, usually used to measure and analyze efficiency for return on investments analysis and things like that. And then there is an activity-based perspective, how each activity is performed with reference to best practice or similar benchmarking opportunities, so to say. And in all these kind of things, when we consider everything, a sustainable aspect or aspect should be included. Energy efficiency. There are many very different ways that really is to be considered when we think about sustainability. But energy is a resource that costs money and resources every second, every minute. For every product made, but also even when products are not made, there are usually at least two things to consider. One is the direct energy required to manufacture a product, but also indirect energies. Energy necessary to maintain the production environment, like lighting, heating, ventilation, and so on, just going as a standby operation. And for the direct energy, the value-adding energy directly connected to the making of the product or components for a product, and auxiliary energy that is required by supporting activities for individual machine and processes that might be needed for the value adding part, so to say. And there is an example in the textbook related to Volvo construction equipment with improvements and illustrating the potential. Now one has to consider that when that is done, of course there is a limit how much can you save really, but what can be concluded is that they reduce the electricity use by more than 20%, and they reduce the idle uses by more than 50%, and they reduce energy costs by approximately 10 million Swedish crowns per year, which is a million euros per year, and energy savings at one plant, at one site, and the energy savings of a lot of energy implemented. So this is a continuous process that once done, it should be a continuous operation to keep it at that way, or even improve further for many reasons, so to say. So it's economical point of view, but also to actually be proactive related to future legislations and directives and so forth, and be more sustainable in the long run. Material efficiency, to analyze how material really is used related to direct material to produce the product and indirect material in the manufacturing process or system, the waste material reasons, and implementing quality metrics and reduce scrap produced. That will be related to lean production in the later lecture. And some specific concerns related to water consumption, which is a scarce source of raw material, so to say, that one have to consider, and toxic materials that can be extremely expensive if dumped in the wrong way. There are a lot of examples of that. Digitalization opportunities, that relates to the fairly large amount of embedded computer systems in manufacturing nowadays. Those allows for monitoring processes, machines, and systems. Actually, if processes are monitored, that then we also get the opportunity to monitor and analyze data related to machines and aggregate that in analyzing the whole system. And in that way also be able to control processes and machines in a better way, and in-process control, of course, related to the quality of what we are doing. And then optimization and simulation-based tests of manufacturing equipment. So especially I mentioned that with the factory acceptance test, that is also going more and more digital. Has started recently, I mean the last couple of years, and that will be seen more and more in the future with what we call digital twin technology, and simulation of production systems and equipment at different levels. Another issue that is also coming in recent years is cybersecurity. So if we apply online remote control or monitoring, so cybersecurity becomes more important than ever, really, and that is something we have to consider. So just concluding with the discussion, so a manufacturing development process evolves in most cases over many, many years. So one or a few products multiplies into many variants over time, and customer requirement changes, and competition changes over time, and new opportunities opens up. And sustainable development is a continuous process. So look out for what's next is really important. And what next includes technology, methods, markets, or competition. And then we have legislation directives that changes as well. There are many ways to look out for that, but as well as political changes, and that relates to a strategic management uh, view over the whole topic. Okay, thank you.